Good morning, everybody. Well, microservices. This is not going to be a highly technical talk. I'm not able, I confess my total ignorance, to talk about and distinguish between pure and impure functions. I mean, to the best of my understanding, and not to say anything on Mark, it was not his fault, it's my fault, but I have no chances to understand what a monad is. Well, in Italian, in some part of Italy, monad also has a sort of kind of sexual meaning. Well, so I'm a little bit confused when I hear monad. Oh my God, what are we talking about? Software? Anyway, I have thank you. I love you guys. Okay, I love you in the back, yeah. Wow. Now, I was talking to the guy that takes care of translating my English to Ukrainian, Russian, whatever language. I mean, they told me it's different, but you Ukraine, right? You Russians, they close to you, but not here. I have microservices, and I didn't know. So this is, in a way, a talk about microservices, about the real substance we can find underneath this overused term. It's about the excess of emphasis, the buzzwords that we hear too often in software, and it applies to anything on the socials, but also on regular blogs, news, technical news, websites, and so forth. Let me start with a quote. Ever tried? So I've been in this industry now for 25-ish years. Next January, I will celebrate 20 years, 20 years of consecutive columns on MSDN magazine. So 20 years in this software industry, I've been told, well, it's much more than a life. I mean, when I started in January of 98, my son, 19, now has still to come to life. So I ever tried in my 25 years of career, I ever failed, no doubt. No matter. I tried again, I failed again, but I failed better. So it's essentially all about failing better. This is not marketing stuff. This is a significant quote from Samuel Beckett, written in around 1983. Samuel Beckett won the Nobel Prize for Literature. And the book, the work where this sentence comes from, has an interesting, attractive title, Worst Word Ho. Worst Word Ho is the paraphrases, the adaptation of the yell that, according to history and anecdotes, people on the boat on the river, the Thames River in London, were used to say to indicate their direction, going east, going west. So it was eastward, ho, westward, ho, and it turned that into worstward, ho. So microservices, with microservices, we're going worstward, ho, going for the worst. What is this? Okay, I'm gonna tell you, relax. Well, how many times, we join a new team and we find the usual smart guy, elegant, freaky guy, says, oh, well, I had a lot of experience in my previous company, and we did a lot of interesting projects. We built this, that, and also that other thing. And, well, I think we should really be considering microservices. Slammed in the face. Don't be silly, go to work. That's it. Be serious. Many times, things look different from what they are. Here is couple of examples. Now, the first picture on the left shows two guys, one that runs away and the other one up. If you look at the picture, trying to kill him, to stab him. But the TV shows only a fragment of that, and it apparently looks completely other way around. So like, what is in reality a food seems to be the weapon that tries to hit the other guy. And also the other picture, more romantic, shows, what does it show really? Someone that tries to play a saxophone, or the face of a beautiful woman appearing from the background. So not always things are exactly what they look like. Microservices are no exception. They are not exactly what we often hear and read about them, and the primary significant difference is that they are essentially part of architecture rather than technology. I think that if you, these days, if you Google for, I'm supposed to say Bing? Okay, let's say Google, that doesn't matter. If we Bing and or Google for microservices, especially if we Bing, chances are that we run into things like Docker, ASP.NET Core. It's technology. Microservices are much more important. So they are a concept completely unrelated from any concrete technology and language, programming language or programming platform. Not that Docker or ASP.NET Core are completely out of place when we talk about microservices, but microservices bring to the project, to the software development process, to the software architecture, bring significant more value. Again, what is this? What I'm gonna tell you, relax. Is a particular way of designing software applications, has a suite of independently deployable services. Now, this definition, this specific quote comes from a guy that everyone mentions as Martin Fowler. I have all of his books in my library, but I mean, not that everything he says has to be, the God style, kind of law. Other people said and totally agree, except that, if you mention Martin Fowler, it's nice. It's cool. Okay, totally, anyway, I totally subscribe to the definition that was taken from the article at the bottom, linked at the bottom. Now, getting to more details. A microservice is particular because it's a piece of software that runs in a dedicated process. What is a process? Is technically an executable, so a piece of software that has its own process space, but it could even be a class library. So another piece of software independently created, to some extent also independently deployed, because a class library can be taken and just dropped into a binary folder, still running in the same process space. But anyway, so it's something that you can treat as an independent piece of software. Now, microservices, because of the first point, they run in total independence, has autonomous entities. They have to communicate, but they ideally communicate through lightweight protocols. And what I mean by lightweight mechanisms or protocols comes in the next slides in a few seconds. Simplified and impossibly automated deployment was me. Decentralized control of languages and data. What do I mean? I wrote that. It's me, not Martin Fowler, it's me. But actually, I'm not really sure what I mean here. Probably I meant to say that you can use any sort of language, okay? to write microservices. I have to check this back. In other words, is SOA just made simpler. Oh my God. I'm able to shock even lions. SOA, service-oriented architecture, has a lot conceptually in common with microservices. Before microservices came, there was SOA. And SOA, what is SOA? Service-oriented architecture, wow. There were the 4 tenets of SOA. SOA was like having an highway with gas stations, pieces of software like gas stations on the highway. And the highway was represented by a family of WS protocols. There was it started 20 years ago. It became formulated much more recently. But okay, let's say 5 years ago, FWS, Federation, this or that, security, this or that. I don't remember. Yet there was a lot of emphasis there, WS protocols to connect like highways, the software gas stations along the street, and SOA tenets. Tenet number 1, boundaries are explicit. Number 2, services are autonomous. Let's stop here for a moment. So, tenet number 1, boundaries are explicit. So whenever you have a piece of software that is compliant with the SOA architecture, the boundaries where it starts and when it finishes, the programming interface, okay, has to be well defined, possibly formulated through an explicit contract, which makes absolutely sense, and it is a concept that is very close to, the idea of a microservice. It's a service. So micro or not, if it's a service, it needs to have explicit boundaries, and it needs to have an API that is explicit. Services are autonomous. They have to be able to stand on their own. Deployed, possibly automated deployment, but they run in kind of isolation, maybe in a separate process, maybe connected to an existing process, but being devised in autonomy. Again, another idea that is familiar with the definition of microservice. Tenet number 2 and number 4 is probably where the difference between microservices and SOA architecture stands, because, microservice, as the name in a way suggests, is a way to have things simplified. And if we started from SOA, the simplification occurs by breaking the list of tenets between number 2 and number 3. Because number 3 is services share schema and contract, not class. Bureaucracy. Tenet number 4, service compatibility, even worse than bureaucracy. It's just law. I mean, it's legalese, so only experts can understand that it's based upon policy. I mean, when I tried to make any effort years ago to try to make sense of SOA, I stopped at tenet number 2 because I'm limited, because of me, because I'm ignorant, because I'm not the great super architect that you guys seem to think. Thank you. I stopped. I couldn't understand better beyond point number 2, beyond tenet number 2. And today we are talking about, the entire world is talking about microservices, and microservices are SOA stopped at tenet number 2. So probably it was not just me. You are with me, at least. So this is now an updated graphics, sort of an highway in orange with gas stations, each of which is an independent piece of software with some characteristics. I put in the graphics cylinders, green cylinders, to indicate local storage, whatever that means. For a few services, the globe, to indicate some sort of internet available feed, and and dashed arrows connecting some gas stations there. So what I want to really communicate with this picture is that a software architecture, an effective software architecture in general terms, is one that has isolated pieces that can even have their own local storage because they are standing on their own. They reasonably could be independent from the deployment point of view, and the connections is not necessarily going through the major orange line, so through APIs, but it could even go through a dashed line connecting, the internals of one module with the internals of another module. So a shared database is a perfectly fine way to have two modules, two microservices to communicate. So it's about what works for you in the end. But now the interesting thing is, if we look at the blocks of code we have, and we imagine that each of those individual components provide a service to the outside world, and we imagine a cage around that encompasses the entire list, the entire set of components, so we have a sort of black box. So we have the entire system made of smaller components, and it's relatively easy to replace any of those, because any gray block can be taken away and replaced. Now, how immediate is this depends on the technologies you may have used. So if you use Docker, for example, I don't know exactly what it is, but it makes cool to mention Docker, because the idea of a container, I have a box here, I replace the container, so let's say it works this way. So if you use Docker, you can just replace the container and it should work. But even if you don't use Docker, even if any of those is, say, a web application, you can just replace the web application, and under the umbrella of the URL, you can replace an MVC, ASP.NET MVC with a PHP-based application. You can even change completely platform, going from .NET to LAMP, as long as the URLs remain the same and the data, the JSON or whatever, being exchanged, the contract remains the same, you can silently and transparently have replaced a block. So the box, the black box that represents your entire system, has pieces internally that can be replaced in a sort of seamless way. So one of the values of modern software is not much how you reuse, but how easy is for you, for the entire architecture, to have pieces totally taken away and replaced, because not efficient, not enough efficient, or not fulfilling the needs. So let's now look again at the definition for a microservice. It's a vertical stack of logic and data, and it can contain replicated data, can access data via services. Easy to package, easy to deploy, easy to assign to a development team. This is another interesting point. It allows sort of parallelization of development in a relatively large corporate. When we say that a microservice is an autonomous piece of software, is a sort of black box, okay, you can have people dedicated to that only need to know how to make their work available to others. Work well, of course, with containers, with Docker, so definitely there is a connection, an obvious connection between the idea, the theoretical idea of a microservice and specific technologies like Docker. It doesn't work that well with Visual Studio. It's Visual Studio, actually, that doesn't work that well with complex solutions. Okay, so let's stop talking about Visual Studio. I recently put online the examples for my next ASP.NET Core book. At the moment, it's probably 40 different examples. So I had the wonderful idea to create a single solution with over 40 different projects and growing. Forget it, especially because I only have business cards. I have no stickers, but I do a bit of work for JetBrains, so I have a ReSharper installed on top of that. Usually, I'm not kidding, I fire up Visual Studio, tell it to load the project, I go for a cup of coffee, literally go for a cup of coffee, okay? And I get back, sit down, take my time, and in a few seconds, I'm ready to start working on a project. So imagine what it could be to use Visual Studio, especially 17, to arrange to have a single solution, okay, to create a microservice-based project. No, more likely you have Visual Studio to, if it's Microsoft, one of the microservices you are going to create, to have probably dedicated to a few people. So to keep the size of the projects to a dimension that Visual Studio can easily handle. But another problem that we face when we try to develop microservices in the context of the .NET stack is how we reuse today pieces of code. And NuGet packages are now replacing entirely plain class libraries. And at least 17 makes it easy to upload your libraries as NuGet packages and link them to another project. So at least there has been this improvement in the area. So microservices are here in this planet, this world, to fight. Let me look at you also, because I tend to stay on this side. So it seems like, okay. So they are, it's because of this. I have to look this, guys. It's better this way. I'm trying to stay this way, sorry. So we are using the term microservice to fight the idea of monolithic applications. Now, when I started, and I think I wrote my very first basic application in '83, I was 18. And you say, you're 18, you're still thinking of basic? You have no girls, no other things in your mind that basic? Well, my wife says that I'm much more interesting as a man now than when I was 18, so probably this is the reason. But anyway, so I was 18, and my main interest in my spare time was writing basic applications. And basic applications of the time had a first line and a last line, so you could say when the software was going to finish. So it was a starting point and an ending point, end-to-end. Classic idea of a monolithic piece of code with a start and a finish. This has changed totally when Windows development became mainstream, because Windows development with a loop of messages, it was never clear because of the asynchronous nature of messages when the software was, you were going to exit the application. You were going to exit the application the moment in which the WM exit message was sent to the message loop. But that was an event taking place asynchronously. So monolithic apps today are something that gives you physical pain, and we want to have monolithic applications to look like segmented applications. So we want to cut in slices of vertical functionalities, which we call a collection of microservices, a monolithic application. And what we obtain, realistically, no irony intended, is a collection of monolithic applications, just smaller. So this is what we achieve, essentially. We have the monolith in mind. We break it up in many other multiple pieces, and what we obtain is more monolithic applications, just smaller. But that is the point. And again, no irony intended. So again, the emphasis on the concept of microservices is right and wrong at the same time. Because every single word, every single sentence that you may have heard and that you will hear about microservices more or less makes sense. But is the context that helps, what is in the background. So microservices is really about breaking a monolith in many multiple monoliths, smaller, and communicating. It's not stupid, or not completely stupid. The point is the size that makes the difference. The size is the manageability of the monoliths you get by slicing vertically an existing monolith application. Here is another view of this that probably gives more the sense of what we have when we try to break up something into microservices. It's the same picture, just with the vertical pieces put one farther from the other, just to give you the sense of the communication that could take place between the modules. And okay, for example, the first one has an arrow connecting down to an orange cylinder representing a database. So we can have a module that has its own database and then communicates, say, probably through a known RESTful or non-RESTful API with another component. And as you can see, these two guys form a micro-universe because they are not connected to the rest of other modules. Then we have three of them connected, sharing a database, another one sharing a database, and the last two connected with a long cylinder that could represent graphically a bus. So the points, the ways in which you may connect the various smaller monoliths that a microservice architecture is made of depends on you, depends on the needs you have, depends on the legacy code you have, the vision of the project you have. So there is no obvious rule. So any dictation like use ASP.NET Core and you're great because you can containerize. I said that, containerize. Yeah, I mean, I exercised a lot to be able to say that, containerized. I love it, containerized. Okay, you use ASP.NET Core and you can containerize your application. I like container. Okay. It works, but it's just one small vision of the entire picture. Now, how do we get there? Now, what I'm trying to do now is the more serious part of the presentation of the talk is is showing you that there is strong theoretical foundation for microservices. So microservices is not something that comes like rain from the sky, but it's something is like rain that originates from the other way around, from the grounds. How do we get there? Okay, all roads, 15? All roads take to Rome. Again, it's up to you how you get to Rome. There is a beautiful reel. This is a clip art But north of Rome, as you take one of the highways going north towards the small city of Viterbo, at some point you drive, there's a crossroad, and you say Viterbo straight, oh cool, then you open your eyes and see Viterbo left and Viterbo right. So you can take any direction, literally, to get to Viterbo. So we have to update the command, not all streets take to Rome, but also to Viterbo. How we get there? Domain-driven design. This is our main route to get to microservices. Now, domain-driven design has two parts in it that are well illustrated in the milestone in the topical book from Eric Evans, the blue book, Domain-Driven Design, except that the order in which these two macro areas are covered in the book is swapped with what today appears to be the original way to learn about it. There is a very interesting video you can find on YouTube from Eric Evans, recorded 5 years later, the publishing of the book, at a conference in London, where he says, literally, if I had to rewrite the book now, 5 years after having done it, I would swap so that people could read. People usually reading cover to cover will get a different order of access to the same information, and the two parts are strategic design and implementation. If you read the book now, you focus first on aspects that can be related to the concept of how to implement domain-driven design, where instead the more interesting part of it is strategic design, which is in the second half of the printed book. Now, the strategic design has to do with patterns like a ubiquitous language, bounded context, and context map, a shared kernel, and a few others, but these are the two most important. Ubiquitous language and primarily bounded context. The implementation part has to do with the things, how you concretely write the software, so it has to do with a layered architecture through which layers you can do, injection of dependencies. And the domain model, which is where you have classes like, the classes that Mark discussed, the maitre d is a class that can be taken from a domain model. But from the perspective of us today, let's ignore implementation, let's also ignore the ubiquitous language and focus on the concept of bounded context. So, according to domain-driven design, and we are talking about analysis of the domain to figure out the top-level architecture. We have a business domain, and we are expected to create a software model for that business domain. This is the purpose of domain-driven design. Software model. Now, software model is often called domain model and is often implemented or presented as an object-oriented model, but it could even easily be a functional model for the domain. In general terms, we are expected as architects to look at a business domain and devise, define, create, think for a software model. Now, depending on how we do this, depending on how we learn and what we find in it, we can find easier to break it up. So to break the single monolithic business domain into areas, functional areas that we find easy to treat as distinct pieces that all together form the set of functions we are expected to provide. Now, in the jargon of domain-driven design, those partitions we identify as architects out of the domain model, the business domain, are called bounded contexts. So the business domain is our monolith that we break up into microservices, but in the DDD language, those are called bounded contexts. Now, a bounded context is characterized, and DDD says that, by three aspects. it has its own ubiquitous language. Ubiquitous language is the grammar, like the grammar behind programming languages or natural languages, the set of rules that define expressions that are correct and legal in that grammar. So it's the language that defines the things, the events, the actions taking place in that domain. It has an independent implementation, and it has an optional external interface to connect the context to other contexts. Now, in other words, to use a visionary image, when we talk about microservices, it's like talking about islands. Every microservice, every bounded context is an island. Islands can stand on their own, but they can be connected to other islands or to the mainland through bridges or ferries or swimming. Every approach is correct as long as it takes from place to place, as long as you have a way to connect two points into distinct islands. Swimming, of course, is harder and cannot be always applied, because if you have to swim, even for a short distance, that you can do that physically, but if in the sea that you have to swim through, if that part is crossed by boats, it's not safe to swim. So you might want to have a bridge or maybe a ferry. So again, this is to say that whatever form of you give to the external interface out of a bounded context depends on the context. So the example of islands just shows that. Not that swimming is wrong per se, not that sharing a database is wrong per se, and you have to go necessarily for an API that is JSON and RESTful. It depends on what you have and what works for you. As long as it works, it's fine. Why having bounded contexts? Essentially, they represent the functional areas of the application that are better treated separately, because it helps you to take the project home sooner and more reliably if you break it up. Also, a bounded context helps when in the overall analysis of the business domain, you find that the same term is confusing. So people in the requirements happen to use the same term to mean different things. So the same term apparently should be modeled through the same soft piece of software, but probably the set of properties you want to attach to this software components is not unique, but to different people, for different people, you may have different sets. That is a significant signal that indicates that you probably are better splitting the responsibilities of that term into, and make two copies of that term with the specific definition for the specific context. Similarly, when the same term use different elements, indicates different elements, or when you have dependencies, necessary dependencies on external subsystems or legacy code. Legacy code is the perfect example of a microservice that you use as a standalone part of the software, connected in the best way you can, even through shared files. Okay? I'm on a project, and there's Microsoft behind this project, right? So my counterpart is Microsoft, is a Microsoft group. Well, they suggested us, we have the two systems to communicate, and they said, what if you write a file in a shared Azure area? So just write a file there, we read the file, and we get the information we need. It makes sense. I mean, given the nature of the project, it makes sense. And is probably the fastest way we have to have the job done in that context. Even though, oh my God, the Microsoft consultant came to me and said, oh, let's share a file. It's a smart kind of approach. So the context map shows how the bounded contexts, plural, can be connected together. Now, the arrows here, the blue boxes are, in a demo that represents an e-commerce system, are possible bounded contexts. And the arrows and the weird letters you find there, D and U, indicate how the two contexts are connected together. U stands for upstream and is the master. D stands for downstream and it's the slave. So when there is a UD connection, it means that the U, in the case the accounting, payment, biz rules, the back end of the system, that is the master. So the team in charge of that piece of the system is the master, is dictating rules. And if something changes in the implementation of the central body, all dependents, all these are required to comply. I made some changes to my API. Is a breaking change? You adapt to it. And supplier or conformist, you may read on UD, master-slave relationships between bounded contexts, indicate the margin of negotiation between the parties. Conformist means no room for negotiation. If something breaks up your code, the dependent code has to adapt, no matter what, period. If it's of supplier type, there is some room for negotiation. Who decides about the arrows? The lead architect, the chief architect. It's the architect. There's a human brains behind the arrows there, and the U's and the D's and the supplier labels or the conformist label. This is domain-driven design. The core part of domain-driven design that goes under the name of strategic design. And the blue boxes there are microservices. So let's say you are a startup. This is, I have microservices and I didn't know, because as the architect of a startup, I ended up with this, in which the black boxes are independent systems. Any system there is an MVC application. But we get this in 5 years, step by step. In the beginning, we only had, the startup operates in the sports industry. We only had a Palm Top, a compact iPack, 5 or more years ago, through which we were collecting data, and we were just passing the data via HTTP to a database, and from that API server, via a web app, we were exposing data out to the public. So live score, and then the view of those scores. At some point, we figured out we had to add information about players and teams, and we created another dedicated server through which people could, in the back office, update the information. We made the player information available to the API server. But then we created a CMS, and the CMS originally contained its own copy of player data, and then later on we just flew, because we had in another place player information we put there in through an API, and then we added more and more components. As you can see, the tournament server, for example, depends on players, but is a standalone kind of thing, because it serves the purpose of providing certain specific services to certain specific customers. The functions behind the tournament server over there have no need to be connected to other parts. So there are 2 islands, player and tournament, with 1 bridge. And from the tournament server, there are no other bridges, no other forms of communication with other bounded contexts in the entire application. If I put a black square around the picture there, I will have a single IT implementation for 1 company. But it's 6 distinct applications that, for our needs, are coded as MVC applications. So I built a perfect microservice architecture without knowing that. And the reason we ended up to microservices had a lot more to do with the productivity rather than pure methods of using cool technologies. Also, let me say that it has a lot more to do with common sense and attitude to solve concrete problems, having job done, rather than religion or, oh, we want to scale because we will be the next Facebook. Microservices also lends to some irony. It's break, the monolith cut into smaller and smaller pieces. This is the new function we have in ReSharper at some point. In the future, extract to microservice. There was a joke about years ago with SOA. Every class as a service. We're going to have probably every variable as a microservice, and ReSharper will support that. To finish off, to finish with a flourish, as English say, George Humphrey, I think is not a developer. I think it's an important psychologist, a scientist anyway. I think it's a psychologist, and this is one of his basic core statement adapted to software. The user of the software won't know what she wants until she sees the software. And there is no irony, there's nothing to laugh about. It's exactly like that. Because software is about understanding what they want and how we can, what we can do to have users and customers do their own things. Now, users that we talk to can share with us requirements, but they cannot share with us an architectural model. It's our job to figure out what they want. But actually, it could be that the info we receive from them is not crystal clear at first run. So until she sees the software, the user can hardly be extremely precise about what they want. And Wegener's lemma of the Humphrey's law, an interactive system can never be fully specified, nor it can be fully tested. Thank you very much for your time.
Well, thank you for such amazing presentation. And if you have some questions, please raise your hand.
Is there one over there?
Yep.
Hi. Dino, could you please return slide from bounded context to microservices?
Which one?
From bounded context to microservices.
Stop me where it is.
Okay.
The one you mean? This?
No, more.
This?
More. This one, yeah.
This one, okay.
So, is it actually a good idea to reuse one database with 3 microservices?
I don't know if it's a good idea, but this is exactly what we have done in the case study that I briefly tried to mention. We have, in that case, a shared database that is being used. The reason is just, in a way, productivity. So it was the fastest way. We had to have the job done. So I'm not sure if it's really... Okay, there is less abstraction. Okay, so you go straight to the point, you get the data, so you have no filter in the middle, so you have no abstraction. So it's if you let me make a joke, is like, being loosely coupled or tightly coupled. I mean, I usually say to my wife, we better stay loosely coupled, the distance. In life is easier, we can make any changes. But when we are tightly coupled, well, it's more fun. So, again, if you go straight to the data, you take exactly what you need in the fastest possible way, at the cost of, if you have to make some changes or you lose control for whatever reason of the database, you have parts of the system that are at risk.
Yeah, but in this situation, you should kind of differentiate microservices with data. Like each microservice control their own tables, because it would be a situation where when one microservice changes some data, and other microservice changes some data also.
It depends. I mean, yeah, I'm not saying that your objections, your comments your remarks are out of place. Absolutely not. It depends on the solution, the time, the context. But my point is that every possible way to solve a problem that really solves that has to be taken into serious account. And the beauty of the overall microservice architecture, where you have really relatively small pieces involved, is that if something is wrong, if you failed, you can try to fix things with much less effort so that you can fail better.
Okay, thank
Okay?
you.
So we are still talking about failures. Okay? The point is how better we can fail in a way. Now, again, so seriously, I mean, I'm not sure if it's a good idea, but sometimes it works.
Okay, thank you.
There was another
Thank you very
question
much.
over there. Or
Unfortunately, we are out of time for your
Out of time?
questions. So thank you, Dino, once more. That was just an amazing presentation. Let's say thank you to our speaker.
Thank you.
And if you will have some questions, you can find our speaker today on our expert coach. Thank you.
There is the expert corner this afternoon, so show up if you have more questions. Thank you again.